Good morning, seventh graders. So, today we are going to be moving forward into another week of online learning. Again, this pace doesn't stop, it keeps going. And this week we're going to be talking about trying to find proportional relationships from graphs. So, taking what we knew about tables and how we find out that they're proportional and using that to take another step further and finding out if a graph can be proportional and what that looks like. So, without further ado, let's get to the video.
All right, everybody. This week we're going to be talking about identifying proportional and non-proportional relationships in graphs. Now, last week we talked about identifying proportional relationships from tables, and part of that was because of the thing that we were looking for was the constant of proportionality. So let me write that out one more time. Constant of proportionality. So the constant of proportionality is just a number, it's a rate, it's a ratio, it is a rate of change. So let me write all these down. Rate, ratio, rate of change. It's all of these things, okay? But it essentially tells us how we can go from X to Y. How we find it, that looks a bit like an F, there we go. How we find it, it's actually pretty easy. What we can do is we can just look at whatever our Y values are and divide X by them. So we can just go Y over X. And that's essentially it. And if we have the same number every single time, that means it's proportional. So let's use this information in order to try to figure out how can we tell if a graph is proportional. But first, we're going to start off with an actual table. So Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the money he received. They want to know, is the amount of candy bars sold proportional to the money Isaiah received? So I can see they already nicely labeled my Y and my X's here for me. So again, all I have to do is Y over X every time to see if I get the same thing. So I have 3/2. I want to know, is that equal to 5/4? Well, in this case, I know that 3 divided by 2 is 1 5/10. And I can tell you that 1 or 5/4 is only going to be 1 25/100. So I know that these are not equal, therefore they are not proportional. How do I know? Well, because of the constant of proportionality. There isn't a consistent constant of proportionality. Oh, another thing I forgot to mention with the constant of proportionality, many times it's referenced as K. K is considered the constant of proportionality. Okay? So, we know that there is no consistent constant of proportionality or K. So, let's take this idea of using a table in order to help us graph. So, on to the next slide, our exploratory challenge. We need to use the ratio provided to create a table that shows money received is proportional to the number of candy bars sold, as in it needs to be able to be divided by y and x and get to 3/2. So in this case, what I'm going to do is I'm just going to use this ratio and I'm going to come up with something. So I'm going to go 4, 6, 8, 6, 9, 12. Okay. And I know that this is right because I could do 3 times 1.5 and I essentially get, or really what I'm doing is I'm doubling this every time, just on both sides. And since I'm doubling it every time, that proportion, that ratio remains the same. So now what I need to do is I need to plot these points, these values onto my graph. So I'm going to go ahead and do that now. So I look at my x values first. I always start with my x values when I'm trying to graph something. So I go to the right 2 and up 3. And let's see if I can do this nice and neat. There we go. Okay, so there's 1. Then I go to the right 4 and up 6. Then I go to the right 6 and up 9. And then 8 to the right 8 and then up 12. So this is what my graph looks like. And what I'm going to do is I'm actually going to put a line on this. Let me put a line with an arrow because that's essentially how graphs are supposed to go. So I can see here that when I make this line, all of my dots fit on the line. And in fact, it starts off at the origin, or it starts at 0. The origin is considered 0, 0. So when it comes to characteristics of graphs and proportional relationships, well, all of the points are on the line. The same line. And the line goes through the origin, 0, 0, which is, let me change my color really quick, which is right in here. That's my origin. So line goes through the origin. So that is all that we're looking for when it comes to trying to find a proportional relationship in a graph. As long as that graph has all of its points are on the same line and that line goes through the origin, then it is considered proportional. So let's try a couple of examples that I already went ahead and plotted beforehand to save us some time. So graph the points from the opening exercise, which I already did. Okay. So now what I need to do is I need to see, can I put these points on a line that goes through the origin? So I'm going to give it a shot. So I'm going to start at 0, 0 here, the origin, and I'm going to drag it so I can have a couple so far, and then it looks like they are not all on the same line. It looks like it's starting to curve. So do I know if this relationship is proportional? Well, I already knew that it wasn't, but just based off of the graph, that's not a great looking A. Based off of the graph, points are not on the same line. So it is not proportional. Let's look at one more example here really quick. So I have graphed the points from the table below, which I already did. So I have my table of values over here, and I can see that I have already plotted them. So again, I'm going to try to create a line, but I can see that nowhere does it go through the origin. So I already know that this isn't going to be proportional. It's asking for similarities to the one that I just did. Well, all of the points kind of fall in a line, close to a line. Let me write this down. Oops, I need to delete that. Cut. Seem to make a line. But the difference is that it doesn't pass through the origin. In fact, even though it starts at a 0 value, it starts all the way up here at 6, which automatically tells me that it's not going to be proportional. And I can think about this in terms of my constant of proportionality. If I do y over x, so I would have 6 over 0 for my first time, well, that relationship is actually undefined because you can't break something down into 0 groups, which would be a problem. So I know that all of my relationships, these relationships right here, their constant proportionality is not going to be undefined. They're going to have different values. But since there's no constants of proportionality, no consistent constant, that automatically tells me it is not proportional. And it's the same thing with the graph as well. It doesn't go through the origin. Even though it seems like all of their points would be on a line, it doesn't go through that 0, 0 point, automatically making it not proportional. So just our little summary page, our lesson summary. When two proportional quantities are graphed on the coordinate plane, the points appear on a line that passes through the origin. And that is our lesson for this week. So if you have any other questions, feel free to message me. You can email me or you can message me on Schoology.